Can you hear me?
Yes.
Awesome. Yeah, thank you so much again for your patience. I appreciate it.
Yeah, no problem. We've been we honestly the that the time zone mix up may have actually worked out in our favor.
Yeah.
Yeah, because yeah, everything has been kind of crazy, and we're I'm currently running as the only judge when there's supposed to be three of
Oh,
us.
nice. I thought, yeah,
So
I actually thought all the people from
That's
RIT,
exciting.
I thought all the people from RIT were judges at first when I joined, so I thought there was like a million judges. So I'm kind of glad I was wrong, but
yeah, no, we're currently running with with just one. So
yeah, we're Cal State Fullerton. We only have 3 out
okay,
of 10 members because we have a lot of
yeah,
people starting work orientation today.
yeah,
And then we have people working right now.
yeah.
So it's only 3 out of 10 of us from Cal State Fullerton today.
All right. So I guess the question. So my first question is. So you guys went with. Oh, cool! Yay! Finally, a team that went with fiberglass. for yeah, finally a team that went with fiberglass for 10K cots. It's like you don't need carbon fiber.
That's exactly what we
Yeah,
thought.
there was a lot of reasons why we didn't choose carbon fiber.
Yeah, so I guess I will go with I will give you the lowball question of why'd you go with fiberglass?
SB, do you want to go first? I have some things I want to say, but SB, if you want to take it first, I got the rest.
Sure. Well, first things first, within our budget and the time frame to get custom slotted carbon fiber pieces, it just would have been outside of our budget. And then looking at simulated stress analysis testing on the tube lengths, we found that it wasn't necessary to have that abundance of strength coming from carbon fiber, that it would have been just as useful using fiberglass. And then through research too, we also found that it had signal interference with the avionics bay. And so to reduce any signal disturbance, we actually chose to stay with fiberglass.
Okay. Yep.
Yeah, that's definitely the first part of it. The second part of it too is this is like the first time a team from our school has gone in this competition. And
Yeah.
especially with COVID too, we didn't want to be too optimistic. So, you
Yeah.
know, from certifications, we know fiberglass works. We're comfortable with fiberglass. We said, we might as well do it as like a first generation team for this project.
Yep. That all makes sense.
Designed by similarity, I guess. It's a good way to put
Yeah.
it.
Yeah. That all makes sense. So, I guess my next question for you is going to be about that interesting fin setup that you have. So what made you go with the system with all of these bolts and with aluminum that whole aluminum assembly, and I think aluminum fins. Did you go with aluminum fins as well? Yeah.
No, we had
No.
a G10 Garolite fins.
Okay. Okay. Cool. Yeah. Holy cow! Half-inch thick.
Yeah, they're thick.
Yeah. Okay. So I guess the question there is why aluminum for all of those internal components, and then why half-inch thick G10?
Two, do you want to start off with the fin can design?
Sure. Yeah. So we decided to go with aluminum because the whole idea of is we want everything to be interchangeable and while still retaining like safety. So at first we were considering using birch wood, that's in like weight reduction and stuff, but we realized that we have to, the whole thing is interchangeable, so we have to keep going in and out with the screw. So aluminum would be the best option for the weight reduction while still allowing us to put it in and take it out without like damaging the part, without like reducing its effectiveness to the component. Yeah.
Okay, so basically just resilience against repetitive strain and basically repetitive tightening
Yeah.
and loosening of bolts.
Yes.
That is finally a good reason to use aluminum. Yeah. And then the half-inch thick G10 fins.
So for the fins, we actually chose half-inch thick because we did fin flutter simulations. And so with the max acceleration and vertical velocity, we found that the fins would have been shearing if it was any thinner, just due to the orientation that brought us to a static margin of 1.5. And to deal with that, we essentially made them more thick. And then as well as the nose cone orientation, we initially started off our design with a 2-to-1 tangent on guide nose cone. And then later on, just for ease of purchasing, there's
Yeah.
pre-manufactured 5-to-1 von Karman.
Yeah.
And so we ended up using that. And then to change our fin orientation to match the static margin that we needed, we actually had to make the fins really thick. Otherwise, they would have sheared off.
Okay. Yep. That makes sense.
I wanted to throw in too, just previous teams from our school that tried to get into this competition have just made just like a very basic fin design, like you would see on like a model rocket, and none of them have done it well. So just working with their senior design professor in the department, we try to come up with our own more unique design.
Yeah. So that makes sense. All right. And then I guess my next question is going to be those dimples on your boat tail. So I was looking at that and I was sort of wondering what's the purpose of that dimpling on the boat tail? Is that aerodynamic, or is that just for ease of screwing it on, or to cut down on weight?
The main goal of that was for cutting down on weight. So we were just messing around. And there was like since a whole aluminum part is actually have a lot of weight, so we're just trying to find our best way to like reduce down the weight. And one of our teammate thought of like, oh, we'll just cut shear into it. It still retain the same function as the whole boat tail, will reduce about half a pound. So I was like, yeah, that'll work, and it looked awesome.
Yeah. Okay.
Yeah.
So you're using Altus Metrum electronics, and then lipos. Cool. So I don't have to ask. So I don't have to ask you the all of the 9-volt battery questions.
Yeah, we I would say again from certification launches, we only use lipos, and just talking to the people there who are running our launches, none of them like 9 volts anyway.
Yeah.
So using them kind of as mentorship with that too, just asking a million questions. That the discussion at the end of the day was the lipos are just better, and then we get the 9 hours too with the 900 milliamperes. Or my bad, we get 6 hours too.
Yeah,
with like 850 and 900 mAh. Yeah,
plenty of power.
Yep.
And they're going to be lighter.
Yep.
So for your payload, was that just a passive glider, or did that have what did that have in terms of electronics components on board?
So inside we have the Pixhawk, which is it's the same device one of the teams at our school uses. We have a glider team at our school, and we didn't copy them by any means, but we wanted to make a glider. We talked to them about some of their electronics just to get a better understanding, and then from there our payload team got the electronics they needed with the Pixhawk. So then they also had the speed controller. It'll also be ran using I think a 3S lipo actually, or 2S.
Yeah.
And then, of course, we have the ground station as well for the Pixhawk.
Okay. Do you know what? So I guess next question is going to be, what did you guys do in terms of range testing, both for your GPS system and for the payload?
Sorry, for the GPS system, for the rocket or the payload, or both?
Both.
Okay, yeah. So for the rocket, we used the devices in certification flights. So I personally got my level 2 using our electronics. And again, because we use, so we have two, we have the Mega and the Metrum.
Yeah.
With the Mega being a little bit more diverse in its capabilities, and because we had success with both, we're pretty confident in the abilities of its use for our rocket with the success we've had.
Okay.
As well as using it as a GPS locator, just because, especially with this decision to use those instead of, I don't know if you're familiar with the Easy Mini, but when I used the Easy Mini for one of my flights, I kind of spent, I want to say, a good 45 minutes just finding my rocket because it doesn't have GPS on it. So that was a very big decision to not have to do that with the rocket going 10,000 feet high, theoretically.
Oh yeah, no, at that altitude, you want GPS. You probably want redundant GPS.
And then for the payload itself, we only have a first prototype, but the electronics themselves, we've working with the talking to the aero team at our school that makes the glider. They use it consistently every year since it's been a project, as well as it was just greatly recommended by every YouTube video channel that makes glider.
Okay. Yeah.
Gliders.
So have you guys done what's your what do you expect the maximum range for the transmitters on given the antennas that you're using for the Telemega, and then for your for the glider as well? What do you expect the maximum range on those will be?
So for the glider, we're not worried at all because we've seen people on YouTube send that same electronic device into the atmosphere and come back down. I don't have a specific number on the actual range, but just for the fact that they were still collecting data the same way we plan to, and again, they use it on a balloon heading the atmosphere. I don't think we have to worry about that at all. For the range of the rocket devices, since we're using a Yagi antenna, 3-element Yagi antenna, I don't think we specifically have to worry about range issues as well with 10,000 feet. I'm blanking out here on the number and range, but talking to the people that do the electronics at our certification launches, they said we don't need to have any, we don't need to worry or have any problems with the Yagi antenna as well. Again, though, I can't remember the range off the top of my head.
Yeah, I don't think it would be a huge issue, but yeah, it's something to make sure you have all of those numbers available in terms of making sure that you have that. And it might be useful to actually do some physical testing of that as well.
Definitely.
Okay. So I think unless I'm missing something, I think that covers all of the questions that I had. It's nice to see a team actually go through a bunch of different stuff for motor selection as well. You guys did a good job there.
Good job too.
Yeah, thanks. Yeah.
Okay. Yeah, I think that's basically all that I have.
Okay.
So thank you guys. And hope you have a nice rest of the day.
Awesome. Thank you.
Thanks so much for having us.
Yeah, thank you.
Okay.